welcome to the course Biomedical Instrumentation in Sensors. Now, your course coordinator currently working as a professor in the Department of Electronics and Telecommunication at Rumta College of Engineering and Technology, Bhilai. I am Dr. Pankaj Kumar Mishra. Now, here in this lecture, we will discuss about data acquisition and processing system. Data acquisition is the process of sampling signals that measure real world physical conditions and converting the resulting samples into digital numeric values that can be manipulated by a computer. The design and implementation of data acquisition system is a complicated field. The first data acquisition system were designed by IBM back in the 1960s and were huge assembles of computers and hardware. The data acquisition system are now used in many different fields, from industrial production to scientific experiments, and the type of system used in different depending on each application. In general, however, types of data acquisition system or DAS can be broken into three components: the sensors used to collect data from the physical system, the circuitry used to pass this data to a computer, and the computer system on which it can be viewed and analyzed. The flow of information in a typical data acquisition system can be described as follows. The input transducer measures some property of the environment. The output from the transducer is conditioned, that is amplified or filtered, etc. The conditioned analog signal is digitized using an A to D converter. The digital information is acquired, processed and recorded by the computer. The computer may then modify the environment by outputting control signals. The digital control signals are converted to analog signals using a digital to analog converter. The analog signals are conditions, for example, amplified and filtered appropriately for an output transducer. The output transducer interacts with the environment, the component of data acquisition system. The components of data acquisition systems include sensors that convert physical parameter to electrical signals, then signal conditioning circuitry to convert sensor signals into a form that can be converted to digital values, then A to D converters which convert conditioned sensor signals to digital values. Now, the basic components of a data acquisition system: the physical phenomena or physical characteristics to be measured comes first in the data collecting process. Temperature, light intensity, vibration, gas pressure, fluid movement and force are a few examples of factors often considered in a data acquisition system. No matter what kind of physical property has to be measured, the physical state must first be unified into a form that a data acquisition system can sample. These alterations are carried out by sensors. An ensemble of software and hardware known as data acquisition system enables the measurement or control of the physical properties of objects in the real world. A full data acquisition system consists of data acquisition system, hardware, sensors, actuators, signal conditioning gear and a computer running DAQ software. Furthermore, an independent timing system must be used if timing is important. Sensors or transducers serve the purpose of interacting with the subject measured. They interact with subject either directly or indirectly, or is defined in other words contact or non-contact. These tools convert the physical values to produce an output of electrical signals. There are many different types of sensors that are utilized in data acquisition system depending on the nature of their application. For instance, when the temperature is being measured, a temperature sensor is used, but when measuring a light, a photoelectric sensor is used. Transmission or signal conditioners, the electrical signals obtained from the sensors may contain noise or other interference and need modification. They could not be used directly as is. The signals might also be weak to a point where the data acquisition system cannot measure them. Hence, additional circuitry is utilized for optimizing the signals. This additional circuitry is known as signal conditioner. Signal conditioning then is the process of optimizing the signal. The signal conditioner makes use of filter circuits for separating the noise from the real signals and utilize an amplification circuit for strengthening the weak signals. These are the two of the most common functions that are solved by transmission or signal conditioners. A suitable signal conditioning circuit can achieve additional process like linearization, calibration and excitation. The selection of signal conditioning circuit is largely depending on the characteristics of sensors employed in the DAQ or data acquisition system. Data acquisition hardware is the hardware that is connected between the sensors and the computer. The hardware is either connected to the computer employing a USB port or through the PCI Express ports that are found on the motherboard. The data acquisition hardware serves to take in the signals from the sensors and then convert them into digital signals that are readable by the computer. This is the function that data acquisition hardware performs. Now, analog to digital converter. These components of data acquisition system serves to convert analog signals into digital signals. These components is at the core of all the acquisition system. This chip serves to take data from the environment and convert it into separate levels that can be interpreted by a processor. These distinct level corresponds to the smallest detectable change that can be found in the measured signals. The higher the number of bits of the analog to digital converter, the greater the number of discrete levels that can be used for representing an analog signal, and the greater the resolution of the analog to digital converter. Then data sampling rate. The sampling rate, known as the frequency or F, capital F, is determined by the nature of the process being monitored. In common sense, with digital data acquisition, transducer output signals to be digitized by a computer. Unfortunately, a computer is unable to store continuous analog time waveforms and breaks the signals into samples that are stored. In essence, the sampling rate or sampling frequency is the number of samples per unit of time taken from a continuous signal, which can be measured in hertz. In aspects of data acquisition that can influence the interpretation of a trend is the sampling rate. If the sampling rate is too slow, important trends may be missed or hidden. The computer is the end piece of a DAQ chain. The computer's function is to gather all the data that comes through a data acquisition hardware for further analysis. However, it is not enough to simply connect the data acquisition hardware to a computer in order to make sense of the data collected. Data acquisition software that uses data from the data acquisition hardware is still required for creating readable and meaningful results. This data acquisition software acts as the layer between the data acquisition hardware and the user. With the data that is collected from the DAS or data acquisition system, computers are critical to perform higher order computations. Now, data acquisition system measurement. Data acquisition systems are capable of making many different types of measurements. These types of measurements are typically derived from the analog signals. Before they are transferred into any computer system, they must be in digital format. Many different parameters can be measured using a data acquisition system, including the following, that is current, voltage, strain, frequency or time interval, pressure, temperature, distance, vibration, angles, digital signals, weight. Now, the separate modules or sensors may be utilized for measuring different specific parameters. Although several multi-input general purpose data acquisition system or devices can interface to these various sensors. The types of sensors that are utilized in data acquisition measurement usually return values of voltage in particular, since these readings can be converted into measurement of temperature, displacement or anything that is being studied. Often a data acquisition module as well as a sensor will make use of a transducer of some kind in order to create a base measurement parameter like voltage. This measurement is known as the primary measurement. It will then be converted into subsequent parameter as required. In this way, data acquisition modules are capable of measuring almost any required parameters which may need to be made or obtained. As a result, the vast arrays of data acquisition system modules which exist are capable of measuring almost anything possible. Additionally, they can meet very specific requirements. Data acquisition software. Specialized data acquisition software required for acquiring, storing and processing data in the logical format is available. Software used in data acquisition subsystem can be written in various languages and can be written for a specific application in mind. Alternatively, there are many different data acquisition software packages available that can be utilized instead. Now, data acquisition transducer signals. Transducers are the electronic devices that change energy from a particular source into an electronic signal depending on the specific variable. The data acquisition system is designed to measure the output signals varies. Data acquisition systems are usually discussed in terms of the output signals they generate. The output signals generated by digital or analog data acquisition signals used by the data acquisition systems the data acquisition signals used by data equation systems, some of the data equation techniques include voltage signal. The voltage signal is the most commonly used signals employed by DAS system, strain gauge bridge circuits, thermocouples and gas concentration probes, for example, all produce a voltage signals. Data equation hardware conditions the signals and then converts it into a digital number by employing an A to D converter. This digital value is stored by the computer. Data equation systems are often able to directly handle low voltage inputs that are to say a few millivolts up to a few volts. Now, current signals. Current signal or current is usually used for transmitting signals in noisy environments, since it is much less affected by environmental background noise. A data equation system measures the amount of current that flows and then stores the value in a computer for analysis. Now, power signals. The signals from electrical power supplies can be monitored when the current signal is sensed within a current sensing resistor, and resistive dividers are used to break down high voltage signals. The current sensing resistors will provide data to data equation system for measurement and storage, so that the power signals can be monitored. Rather, the voltage depends on the difference in temperature between its two wires made of two different metals collected at the thermocouple junction, where the wires meet in the temperature of the cold junction, the point where the thermocouples wires terminate. Thermocouples. These sensors provide a low voltage signals, that is typically a few millivolts. The relationship between the voltage and temperature is nonlinear. The accuracy of thermocouple will vary accordingly to the type of thermocouple being used. Resistance measurement are performed employing a current source together with a normal voltage input. The current flows through an unknown resistance and the voltage drop across that resistance is measured. This voltage drop is then recorded by the data equation system. Then strain gauge bridges. These bridges provide a special case of resistance measurement. Strain gauge bridges operate on the principle of electrical conductance and its dependence on the geometry of the conductor. A Wheatstone bridge arrangement is utilized for measuring the resistance of the gauge, which will vary as the gauge is distorted by an applied strain. They measure the small difference between a Wheatstone bridge two circuits. Consequently, the measurement of strain is often concerned with the measurement of deviation from the initial values instead of absolute measurement. The initial values therefore must be known. These may be sufficiently larger than the subsequent changes that occur in the bridge imbalance caused by imposed strain. Therefore, an analog to digital converter with high resolution is employed to give the dynamic signal range that is required. Now, digital signal. Digital output produced by the switches and so on are treated as a logic signals. These signals are sensed as a 1 or 0, 1 for on and 0 for off. For volt free contexts where there is no switching of external voltage, a small sensing voltage is applied for determining the switch state. This will usually the 5 volt to be compatible with TTL levels where voltage is being switched. The logic state can be determined by the voltage level itself. The type of input required is determined by the voltage level. For example, up to 12 volt logic to 14 volt DC. When the digital signals are rapidly changing and become pulse trains, counter timer type inputs must be considered. Now, types of data equation system. Data equation system can be classified into following two types: analog data equation system or digital data equation system. Analog data equation system, the data equation system which can be operated with analog signals are known as analog data equation system. Following are the blocks of analog data equation system. Transducer, it converts physical quantities into electrical signal. Signal conditioner, it performs the functions like amplification and selection of desired portion of the signal. Display device, it display the input signals for monitoring purpose. Graphic recording instrument, these can be used to make the record of input data permanently. Magnetic tape instrument, it is used for acquiring, storing and reproducing of input data. Now, following are the blocks of digital data equation system. Again, transducer convert physical quantities to electrical signals. Signal conditioner, that will perform amplification or selection of desired portion of the signal. Then multiplexers, the multiplexers accepts multiple analog inputs and connects them subsequently to one measuring instruments. The next one is A to D converter, it converts the analog voltage to its equivalent digital form. The output of the analog to digital converter may be fed to the digital display device for display or to the digital recorders for recording. The same signals may be fed to the digital computer for data reduction or further processing. In the display device, it displays the data in digital format. Digital recorder, they record the information in digital form. The digital information is stored or punched called magnetic tape recorders. Type return pages, floppies or combinations of these system. The digital printer used provides a high quality hard copy for record, thus minimizing the operator's work. Now, the essential function of digital data equation systems are as follows: it handles the analog signals, it performs measurement, it converts analog signal into digital data and handles it, it performs internal programming and control. The data equation system is used nowadays in increasing wide fields. These are becoming very much popular because of simplicity, accuracy and most important reliability of the system. These are widely used in industrial area, scientific area including aerospace, biomedical and telemetry industries. When the lower accuracy is tolerable or when wide frequency bandwidth is needed, the analog data equation system are used. The digital data equation system are used when the physical quantity being measured has very narrow bandwidth. When the high accuracy with low per channel cost is required, the ultimate solution is used to digital data equation system. Now, application of data equation system, these includes in electronics. Data equation system are utilized in the electronics industry. They are utilized in the testing of many variables that are involved in the design of electronics like heat production, resistance, conductivity, magnetic magnetics, etc. Automotive industries, data acquisition devices are utilized in automotive manufacturing for testing the quality of the parts that are manufactured. Imaging, data acquisition systems are used for the quality testing or imaging equipment like a photographic lens or video cameras, as well as with scientific equipment such as scanners and microscopes. Laser technology, data acquisition systems are utilized in the laser technology to test laser performance, light intensity and color. Sonar radar, data acquisition systems are remote sensing technologies within radar and sonar applications to calculate their efficiencies and effectiveness. Now, industrial machines are created to perform multiple times. Therefore, repeatedly of the crucial importance, data acquisition systems are often utilized for testing these machines for their tolerance to repetitive force. Non-destructive testing, data acquisition systems are utilized in the non-destructive testing of structures, geology, seismology, ultrasonic measurement, as well as with the analysis of acoustic emission phenomena. Gas detection are used to find leaks using tracer gases such hydrogen and helium. Once chamber is filled with the trace gas, the loss of gas is measured with a mass spectrometer that detects the trace gas. Gas detection is used to determine the amount and composition of the gas being lost from a system or machine. Benefits of data acquisition system. The advantage of data acquisition system includes accuracy. The data acquisition systems maximize the absolute accuracy of measurement. Then flexibility, data acquisition systems make it possible to build mixed measurement system that are tailored to specific needs. Then scalable, there are variety of hardware options available ranging from processing just limited data to control of multiple data acquisition system. Now, quality control. Data acquisition systems are capable of confirming that a system is meeting the design specification so that a product meets the needs of the user. Furthermore, these systems provide testing capabilities to see whether a product has required quality prior to production. They also provide a means to analyze those products that are effective. Now, data acquisition systems are highly versatile. Data acquisition systems are multi-purpose devices. They can have an all-in-one configurations with multiple measuring modes that are capable of measuring multiple properties. They can also be single purpose device that will only measure a single property. Better file processing and transfer capabilities. The data that is collected through a data acquisition system is stored on a computer where it can be analyzed or processed based on the convenience of the user. Also, any additional transfer of data to other devices that may be required is made easier through a computer. Now, data acquisition system allow one to obtain valuable information without bias for improving the performance of a company and for increasing their economic well-being. Data acquisition system offer greater control over the process of an organization as well as a quicker response to any failure that might occur. Data acquisition system not only work to improve and maximize an organization efficiency, they also work to maximize the quality of their products and services. Now, data logger. A data logger is an instrument that monitors and records changes in conditions over time. They can be single standalone units or consist of multiple channels. Most standalone units are battery powered, allowing them to record while in transit and from extended periods of time. Data logging is the process whereby collected data is recorded. This data is collected over a defined amount of time. Data loggers tends to be small and they are mostly used for the measurement of relatively small signals. Many of these data acquisition systems are intended for the collection of data over a long period of time. Now, depending on the type of application, the data can be used to read temperature measurements, humidity levels, currents or other signals of interest. Data loggers are self-contained data acquisition system with built-in processors and predefined software embedded in the unit. Is capable of running as a standalone device. Data loggers are popular due to their portability as well as ease of use for a specific task. Every data logger consists of local storage capacity for saving data. Some data logger include secure digits slots as a means for providing additional memory through the utilization of memory cards. The data may be collected and temporarily stored in an individual data logger and then sent via data link at regular convenient intervals. Some data loggers are battery powered for additional portability. By definition, a data logger will consist of a more limited set of inputs and tend to have a more basic format like the already mentioned signal including temperature, current, voltages, etc. The data loggers can also be used for collection of geological data for long term monitoring or many times. Now, conclusion of this lecture is that data acquisition system are process for capturing, storing, analyzing and manipulating data. The data is acquired through different techniques including voltage signals, current signals, power signals, etc. These are different types of data acquisition systems utilized. Some of them are multi-purpose device with an all-in-one configuration, whereas some of single purpose devices designed for measuring data from single parameters. Okay, thank you.